To simplify and evaluate expressions with rational exponents. These are two general rules you need to know. If you have a fractional exponent, the denominator is the root, and then the top number is the exponent. Such as if you have a to the m over n power, then your n is the root to the left of the radical, and then the m is the exponent of the result of all of this. We will do some practice on this now. 144 to the half power is the same thing as saying the square root of 144. We don't write the 2 here normally for a square root, so the answer would simply be 12. 16 to the 3/4 power. 16, and then that would be the fourth root, and then the third power of everything. The fourth root of 16 is 2. And then to the third power would be 8. If you don't know how to do fractional powers on a calculator to get a numeric answer, and not something that can only just be simplified a little bit, you type in the number 16, hit the caret, left-hand parenthesis, 1 divided by, well, actually in this case it would be 3 divided by 4, and then right-hand parenthesis. 16 caret, parenthesis, 3 divided by 4, right-hand parenthesis. And that'll give you an 8 when it comes back out. Negative 125, and you want that to the 2/3 power, so it would be the third root of a negative 125, but then all of that would have to be squared. The third root of a negative 125 would be a negative 5, but if you square that, you get an answer of 25. All of this should be reviewed from Algebra 2. We're reviewing it now because you're going to be doing something else with it here shortly. This is supposed to be the introductory to what comes next. And 100 to the negative half power. Now anytime you have a negative power, what that does is it switches what you have to the denominator of a fraction and turns it into 1 over 100 to the half power. And the exponent becomes positive. Then it's 1 over the square root of 100. And of course that would be 1 over 10. One last example. 16, and the bottom is 2, so that's a square root, and then cube the result. The square root of 16 is 4 to the third power, would be 64. Drop this one off. Solution for the practice is that you need the cube root of 125 and then square the result. The cube of 125 is 5, squared will be 25. Another example problem. You have the cube root of 64 squared. You can rewrite that as the following. 64 to the 2/3 power. And then evaluate it down however you have to get to 16. Again, you can put that in the calculator as 64 caret parenthesis 2/3 and then right-hand parenthesis. Or you could have done 64 squared and then do whatever the result is, caret to the 1/3 power. That would still give you the right answer. Another example, same deal with this one. You could write it as 120 to the 6 over 8 power, which is the same thing as 120 to the 3/4 power. And whatever you have to do to get down to the final answer, you should end up with 36.26. 36.26 if you round to the hundredths place. And we'll choose the hundredths place for anything that we have to round on these problems. One more example. On this one you have a negative 7. So that's the same thing as saying a negative 7 to the 1/5 power. If you type in negative 7 to the 1/5 power on your calculator, you should come back with a negative 1.48 if you round to the hundredths place. Again, you would put that in as negative 7. I would still put parentheses around it and then do this to the 1/5 power. You should get this. Tell me what the answer should be for this one. Drop this off. This is the same thing as 20, negative 20, to the 1/7 power, which comes out to be negative 1.53. In this problem, you have 2x to the 4/7 power, y to the 1/5 power. That's an entire quantity multiplied against the quantity of 5x to the 3/14 power times y to the 2/5 power. What you need to do here is just simplify it. If you're multiplying these two quantities together, there's no addition or subtraction inside, so it's not a FOIL method, it's just straight multiplication. Multiply the x terms to get 10x to the 4/7 plus 3/14 power, and then with the y's you have this and this, so it's y to the 1/5 plus 2/5 power. Go back and simplify that. For the 10x part, you need a common denominator, which has got to be 14. So it's going to make this 8 over 14 for the first fraction. 8 plus 3 is 11. So 10x to the 11/14 power. And then we have y to the 1/5 plus 2/5, which would be y to the 3/5 power. And that's it. That's all you can do with that right now. The quantity of, or the quantity to the half power of negative half power is 4x squared z to the negative 4 over 9y to the third. Anytime you have a negative exponent, it's going to flip what you have. So step 1 is to simply write y, or 9y to the third, over 4x squared z to the negative 4th. And that will make everything to the half power instead of the negative half power. Now you must distribute that half power to everything on the inside, including the coefficients. So you're going to come up with 9 to the half power, y to the 3/2 power, over 4 to the half power, x to the first power, and we're going to write 1 just this once, and then z to the negative 2 power. From there, simplify whatever you can, and you're going to have 9 to the half power, which is really 3, and keep y to the 3/2. On the bottom, you'll have a 2. 4 to the half power is 2. The x is okay, but now we have z to the negative 2 power. Anything with a negative power is going to move it to the opposite side. So instead of z to the negative 2 on the bottom, you're going to have z to the positive 2 on the top. And that's all you can do with this. On this one, you have a fourth root underneath a cube root. Now don't forget, you can still write these in terms of parentheses and fractional exponents. So for the larger outside portion, which would be this, that's to the 1/3 power because it's a cube. But inside of it, you have another quantity that's to the 1/4 power. And that would be this item here. x to the 36th power, y to the negative 5th power. You can simplify these two exponents here. Anytime you have exponents consecutively separated by parentheses, you don't add them together, you multiply. So you end up with x to the 36th power and y to the negative 5th to the 1/12th power. Now you have to distribute the 1/12th to everything inside. So x to the 36 times 1/12 would really be x to the third. 36 over 12 is 3. And then you'll have y to the negative 5 over 12 power. The negative 5 over 12 power is going to bump the y to the bottom. So you'll have x to the third over y to the 5/12 power. And there's nothing you can do after that that's going to mean anything. That's all we need. Checks.